Hello, my name is Luna Magpili, and I'm a faculty here at Washington State University's Engineering and Technology Management program. You're probably asking yourself, what's with a bullwhip? Well, one of the courses that we offer is supply chain management, and a common phenomenon found in many supply chains is what we call the bullwhip effect. So what is the bullwhip effect? So to help us understand, I'm going to do a simulation and talk through a game that we play in the class. So this is a simulation that I play in my class. It's called the Near Beer Game by For You Simulate. And it is actually a variation of the original MIT beer game based on the article Bullwhips and Beer, Why Supply Chain Management is So Different. Okay. So the scenario here is that you are a mom and pop's microbrewery, and your task is to order raw materials from your vendors, and this feeds into the brewing process. It takes 1 week for raw material orders to be ordered, okay? And it takes 1 more week for vendors to deliver ingredients after they get your order. It takes another week to brew the beer, and then the beer is placed in the stock room where it sits as finished goods inventory. Now the customer orders come in and the beer is supplied from the finished goods inventory. Okay. So on week 1, you see here that there are 10 new orders from the customer, right there. And you have 30 beers in the pipeline, 10 in inventory, 10 in the brewing process, and 10 in transit. So how much raw material should you order? Well, it looks like it's business as usual, so you just ordered 10 beers worth of yeast and hops. Okay? Now in week 2, you can see here that you have 15 new orders from the customer. So new orders from the customer increased by 5, from 10 to 15. And if you recall, you only had 10 beers in inventory. So that results in 5 unfilled orders. So what do? You brew more beer and increase production, which would entail for you to order more raw materials. So you increase your raw material orders, right? And on week 3, you still have a lot of unfilled orders. Customers are clamoring for your beer and you don't have enough beer available. So again, you increase your raw material orders so that you can increase your production. On week 4, your customers are annoyed. You still don't have enough beer to serve them. And so you keep increasing your raw material orders until, okay, on week 7, you're actually able to match your supply with your demand. So on week 7, you cover your new orders from the customer as well as your unfilled orders, okay? But with that memory of a stockout event, the tendency is to keep ordering at high levels. So you keep ordering 35 beers worth of raw materials, and you keep producing that much beer. But then what happens is your finished goods inventory starts piling up. And you're thinking now, well, I probably need to cut back on production. So you decrease your raw material orders, and you keep on decreasing, but then things have already been set in motion, and your inventory just balloons to a point where there's just nowhere to put your beer anymore. And you're thinking, on week 12, I probably should just suspend my orders of raw materials and suspend my brewing process and just try to get my inventory out the door as much as I can by probably giving discounts and doing price reductions for your beer. So did the simulation sound familiar to you? Well, it's pretty common in practice. You can still find the bullwhip effect actually happening in a lot of supply chains. It's so common that when stockouts occur, the tendency is for us to overproduce. And when inventory balloons, what we try to do is cut back in production, apply the brakes on, and try to push inventory out the door as much as we can. So inventory cycles up and down, as we react to overstocks and stockouts. Either way, though, what always happens is we tend to overcorrect. Now, I wonder if you noticed that the variability of the customer was really small. The customer orders increased just one time from 10 to 15 beers. And that resulted in a lot of variability from our end. As we were reacting to that small change, our orders varied from a low of 0 to a high of 35. And we would expect then our suppliers to actually have even more variability as they were reacting to our erratic and very uneven ordering behavior. Okay? And so this leads us to the figure here. In general, you see the bullwhip effect looking like this, where order variability increases as you go up the supply chain. So consumers have a small variability, the customer demand, and then when it goes to the retailer, the distributor, the manufacturer, and onto the supplier, the order variability increases significantly, especially in the supplier end of it. Okay? And what does this look like to you? Right? This looks like a bullwhip. So we go back to the bullwhip, right? The bullwhips represents the supply chain, and the handle is our customer. As you move the handle slightly, what does it do? It creates a growing ripple that moves across the whip. Okay? And that slight movement in the handle, that's the small change in the customer demand. And that growing ripple that moves across the whip, that's the variability that we talked about, where it increases significantly until it hits the far end of the supply chain. Okay? So you're thinking this might not be really good for business, right? So what can we do? What can we do? Well, let's start with a don't. Don't panic or overreact when stockouts and backlogs occur, because this tends to encourage behavior that promotes the bullwhip effect. So we don't want to do that. Instead, what we should do is work with our suppliers to do two basic things. One is to reduce lead time of information, okay? Reduce lead time of correct information. This allows businesses to respond appropriately. So in our simulation, if you can imagine the supplier actually having the real or the actual customer order, then they would have responded better if they had the true demand information versus reacting to our order pattern, right? And then second, we should try to reduce lead time of material goods. By reducing the lead time of materials or goods, then we can respond faster to changes in customer demand. Okay? So in our simulation, our lead time was what? Weeks. Now, if we had been able to reduce the lead time to days instead of weeks, then we would have been able to deal with the backlog much, much sooner. Probably days instead of the 7 weeks that it took for us to catch up with the backlog. And so we can only do this when we foster a good and close relationship with our supplier. Okay? So the bullwhip actually reminds us that we are all connected. Sometimes cascades or magnifies bad effects. The bullwhip also helps us connect to the supply chain where we can work together, right, to develop good designs, work together to make better products, work together to provide better service, and also work together to create a better experience for all our customers. In the end, everybody wins. So the next time you come across a bullwhip or you're having beers with your friends, you can tell them all about supply chain management. Thank you, and this is Luna Magpili for WSU ETM.